Thank you everyone watching this video. I'm Saravnan and we're going to start our first step in the big data journey using Apache Spark and Java. In the next few minutes, we're going to design the architecture of an application that can process massive data in a scalable way. The problem that we are trying to solve is to process stock quotes data for all listed companies for all years to determine the relative upside or downside of a stock between one business day. Example, Apple stock's EOD price on September 1st is $164.05 and on August 31st it was $164. The relative stock price is 1.003125. This calculation should be done for every business day for all stocks and for all years for which data is available. You can easily download this data from finance.yahoo.com for a particular stock ticker. So if you want data for Google, you'll have to download it again. It may be cumbersome, but financial companies get this data from providers like Capital One or S&P or Bloomberg or Reuters. Consider we get one single huge file, which was obviously zipped up, that contains all data. So it could spawn like gigabytes, terabytes too. In traditional file processing application written in Java, we would write a Java program to read the file and process the data. This would work only for small files. But when the file is beyond gigabytes, God knows when our program will complete its processing. Multi-threading is definitely an option. Instead of having one thread doing the entire job, we could spawn multiple threads and let each thread do some work. Multi-threading in a single file may be cumbersome. You can still do it, but you will have to use the cursor, seek, based on the file size, things like that. One other option is to split the files to as many as we want and let each thread in our Java program to handle each split. It will still work, but where it could go wrong? Throughput of your application is directly proportional to the number of cores because we are running it on a single machine. What else we can do? We can utilize many servers where we could run a Java program. From the high level, we want to process the many splits from multiple threads and multiple servers by hosting our Java program on several servers. Is that simple? No. In order for multiple hosts to access the split files, they need to be hosted in a shared drive mounted on each host. It is easy to overcome this. It's not really a problem. It's a pure infrastructure setup and is available in almost all IT infrastructure. But the next problem appears to be managing all the various Java processes because we need to signal the Java process to process a particular file and ensure it completes it. So, we will introduce a master program that distributes work between all other workers. Let's not worry about the failover and crash issues right now. Other than that, is everything okay now? Maybe not. Because we are not processing the file and put it into a database like that. The kind of calculation we want to do is a relative calculation. We want to compare or calculate based on the previous business day's data with the current business day's data for a particular stock for every business day. That means the data that we are splitting could be co-located anywhere. That means Apple stock price could be in one file or it could be the other day's data could be in another file. So what will really happen is that a particular August 31st data could be read by a Java process on server A. The Google's data by Java process on server B. But server B could have Apple's September 1st data. So what is the solution to bring the data together? One solution is to move the similar data together to a single process so that we can calculate the relative movement. That is, we shuffle the data. It needs to be orchestrated well so that the similar data from various processes are grouped together in a single process to efficiently calculate the data in memory. There could be thousands of stock tickers, and we are trying to rearrange each stock ticker's data in a single process to do relative processing. Once the data is grouped, then the calculation is no brainer. We still have issues with the design. What if the stock files need to be split more than 9? What if the data grows? What if we need to increase the number of Java processes and servers that host them? We need to worry about shuffling between all these processes. We have to worry about failover mechanisms. Even still, we can make the design work actually. Anyway, congratulations. You've understood the complexity. If you've understood the complexity in what we went through, you just designed a mini big data processing framework. In our design, the shared file system is actually called HDFS. The splits of the file is called partitions. The Java process are hosted in worker nodes, and the master Java process is called the master node. This is only a quick view of the design. We'll delve more into these in the upcoming lectures. Thank you. Hope to see you in the next lecture.